So one of our first worked problems for today gives us a triangle which has an inscribed circle. You can see the center of the circle is marked 0, or O, because it's circle O. We have an angle in here that is an unknown x degrees. This outside angle here in the corner of the triangle is marked as 60 degrees. The side length from C to this tangent point right here, point of tangency, is 3. Same here from A to this point of tangency, from B to this point of tangency. And the first question that they ask us is to find the perimeter of that triangle. Now in doing so, you might take a while and look at it because there's lots of red herrings that we've talked about before, things that you maybe don't necessarily need. And so when we're thinking about this, you want to go back to whatever formula sheet that you have for this chapter. Could be a page like this, could be separate note cards, could be just a notebook page in your book. But you need to have all these formulas out for you to be able to take a look and see. And what I notice here is that these two tangents to the circle look a lot like the drawing that I have. If we think about those edges going in and making a triangle, we can see that these two legs of that triangle make actually two tangents to the circle. So when we're looking here, we can see that this line AC and AB both produce tangents to that circle. And we know that if you have two lines which are tangent to the same circle, and they intersect at a point in space, they're congruent. So that means that this line here is 2, then this one also has to be 2. And then we can take the same piece out here with B. B intersects at a point and produces two lines that are tangent to the same circle, which means that these two lines need to be congruent. Coming down in the same corner here, we can see that for C it's the same. There's a tangent here, so this gives us 3. Now in order to find that perimeter, we just need to add, got a little ahead of myself, 5 plus 5 plus 3 plus 3 plus 2 plus 2, and that should be able to add those up, and that gives me 10, 16, and then 20. So my perimeter for this triangle ABC should be 20 units. The second thing it's going to ask us next is the next problem goes in and tells us that this line OB is equal to the square root of 28. And they want us to find the radius of the circle. So in doing so, the first thing we need to agree on is that the radius is from here to the center point to any point along the circle. So from here to here is a radius, here to here is a radius, here to here is also a radius. Now since it gives us OB, which goes from here to here, actually I'm going to move that over and mark the R there. So I know that this whole line is the square root of 28 from O to B. So when I'm looking at this, I now can see that I have a right triangle here. And we know, if I kind of redraw this right triangle here, that the hypotenuse, oh that's a sad triangle, is the square root of 28. It is a right triangle. That the height of that, or one leg, is R, and the other then, because of this tangent here, we know that it's 5. So I can use my Pythagorean theorem to be able to solve for R. So I'll have a squared plus b squared equals c squared. My c is the square root of 28. That needs to be squared. Remember the hypotenuse is always the longest side, which goes in for c. And then I'll have a squared plus 5 squared. Now a squared plus 25 equals the square root of 28 squared. So if I have the square root and the square, they cancel each other out. So that'll just be equal to 28. Subtract 5 on both, or 25 on both sides, and I should end up with a squared is 3. Because 28 minus 25 is 3. So once I square root both sides to solve for it, I end up with a being the square root of 3. So the radius of this circle is the square root of 3. So the next one actually involves a couple theorems that maybe weren't on the review sheet, but I thought we should take a look at them anyway. If you see here, I have a circle and it has a center point, and then it has two chords in the circle. But if you notice, those chords are both equidistant from the center. And if you remember, we have a theorem in here that tells us that if a chord is equidistant from the center as another chord, then those two chords have to be congruent. At the same time, if two chords are congruent, then they also have to be equidistant from the center. So in this case, they're asking us to first find x, which is this length here, and then also the second piece is to find y. So this takes a little bit of rationing, so you have to follow along with me here. So because this distance from the center point to the chord is 5, and from this center point to the chord is also 5, that means that this chord is the same length as this one. Now you also notice that this one tells us that this chord is bisected. So this chord is 9 units long. And this one is also 9, but it's cut into 2 equal parts. So we can cut that length of 9 into 2 equal parts, and we get 5.5. So our value for x should be 4.5 units. I think I mistakenly said 5.5. Sorry about that, guys. It's getting a little late. It's been a long day. So this should be 4.5 units now. So my x value should be 4.5. I'm going to go ahead and mark that in there. Now the next one asks us to go in and find y. Now we also know that when this radius here, or it's not really a full radius, but when it intersects that chord, we know that it forms a 90-degree angle, just like this one does over here. So the next part asks us to find y. And this takes a little bit of kind of reworking, if you will, a little re-hypothesizing. So when we think about this y, I need you to imagine that this radius doesn't just stay there, but can actually sweep its way around the circle. And I want you to imagine it sweeping over to this point. Now once that radius y has swept over there, what we're left with is a nice right triangle with y as the length here at the hypotenuse, 5 as the height, and then 4.5, which is the distance that we just solved in the last problem. And I can go back to my old friend Pythagoras and use my a squared plus b squared equals c squared to be able to solve this equation. So you should all be able to tell me that 5 squared is 25. 4.5 squared, you might struggle a little bit more with. It's actually 20.25. And then when we add those two together, we should get 45.25, which is equal to c squared. And then to solve and get rid of the square, we need to square root both sides. And so when we take the square root of 45.25, we're left with approximately 6.7 units. And that gives us then the radius of the circle. So I have just 2 more sample problems for you. This next one here, you can see we're looking at the measure of the tangent and the secant, which goes through our circle. In this one, we know that the measure of the tangent is 15, and then we know that the secant, the whole part of it is x plus 10, and then the part outside the circle is 10. So we can use our formula, which tells us the tangent squared is equal to the whole secant times the part outside of the circle. And so I can also plug this one in here, the t squared for 15 squared equals x plus 10 times 10. 15 squared is 225, and then that gives us x plus 10 times 10. I can actually divide both of those by 10. And then I'm given, so I was dividing both sides by 10. And that means 22.5 equals x plus 10, subtract 10 on both sides to get x by itself, and I get x equals 12.5. So the length of this tangent inside is 12.5. If my problem were asking for the length of the whole piece, that would be 22.5, and then the tangent piece is 15. So this last one asks you to give the standard equation for a circle that has a radius of 5 and then has its center at -3 and -4. Now I wrote again over here for you on the side the standard equation for a circle, and so we're just going to plug in the 2 points. Since this is the center, we'll plug in the h and the k value. Remember, this center is in that same order, h and k. So for h, I'm going to plug in -3. And then watch, because you've got a double negative there. And then for y, I'm going to plug in -4. And again, you've got a double negative. And then for the radius, I'm going to plug in 5. Now I can just go through and rewrite this. So I've got x plus 3 squared plus y plus 4 squared equals 25. And that's essentially the standard equation for a circle. So this is one last look at all the formulas and theorems that you should have. I did also include up here in the top the circle where you have 2 chords, which are the same distance from the circle. Then our 2 chords, let's call those DA-WN again. That's very creative, right? So on this one, chord DA is going to be congruent to WN because they're both equidistant from the center of the circle. So the chords are equidistant if they are, the chords are equal length if they're equidistant, and if they're equal length, then they're also equidistant. These are all of the formulas, theorems that you'll need for the quiz. Make sure that you have them all written down. This activity that you did on the locus points will not be on the quiz, so you don't need to worry about that. That was an activity. If you have questions, just come and ask Miss P or I. Thanks.